Good afternoon everyone, I am Mr. Thank you for joining me for this video. I'm showing you here an interesting organic chemistry synthesis only because there's a high educational value in it, and frequently students will find a synthesis reaction like this come up on their exam. 1,3-dibromobenzene. 1,3-dibromobenzene. Here's your benzene molecule, here's your first bromine, and then right here bromine number 2. Position number 1, position number 2, position number 3, 1,3-dibromobenzene. How can you synthesize it knowing that bromine is a ortho-para directing substituent? It's not by any means meta. If you were to bring here a benzene molecule and put a bromine on it and you end up with bromobenzene, you cannot do another reaction with the bromine in the presence of a catalyst and then expect that you will end up here at your end result 1,3-dibromobenzene, because it's an ortho-para director. It's either going to add over here, it's going to add over here, it's never going to add over here. So how can you go about doing this? Keep in mind also this one specific fact: even though bromine is an ortho-para directing substituent on a benzene ring, it is deactivating, it's not activating, it deactivates the benzene ring, even though it behaves similarly to activating substituents like alkyl groups or hydroxyl or amino groups, but this right here is a deactivating group. All of that has to be kept in mind. Start here with the benzene ring and nitrate it, HNO3 H2SO4, and you get nitrobenzene. NO2 will form here and it will take any position, but that any position will always be numbered 1. What will we do with it? Keep in mind this is a meta-directing compound and it deactivates. It greatly deactivates your benzene ring. So we're going to convert it. We're going to reduce this. How will we reduce it? SNHCl. What is this? 10 hydrochloric acid. And then it's going to convert it into aniline, which is an amino group. Aniline is the name of this compound and it's called this. Many of you are familiar with it, aniline. Now we have a compound on that benzene ring which is ortho-para directing more so than bromine. This is here an ortho-para directing substituent, but it's more so than bromine, and it's activating to the benzene ring. It activates the benzene ring. This deactivates it, but this activates it. What we will do here, and there are multiple ways, I'm just showing you a good way. You're going to hit this with H2SO4 SO3. The reason for that will become apparent. I have here a sulfonic acid develop para SO3H. I have blocked the meta position. It's blocked. When we have used this and we've literally blocked this area, we're good, because now when we hit it with bromine, Br2 FeBr3, it's a catalyst, Lewis acid, and this right here is your bromine diatomic. What you're doing here is converting this into a electrophile bromine, and you'll have an electrophilic attack on the benzene ring, which is how the bromine will attach. Anyhow, when you do this, you'll arrive at this substituent right over here. Here you have your blocking compound SO3H. Bromine will add right over here. Obviously this is ortho-para directing. The para position is blocked. It can only add ortho to it. We have bromine come over here. So this is step number 1. Do it again. Step number 2, Br2 and then FeBr3. When you do it, you're going to add your bromine right over here, ortho to this. It could technically add para to the bromine and end up right here, but it won't, because when you compare both of these in terms of their ortho and para directing, this beats that. Hence, the next second bromine atom will attach ortho to your amino group and won't attach para to your bromine group. Now you only have 2 things to do. Get rid of this and get rid of this, and we can. So we find ourselves over here. Water, acid, heat, it'll get rid of it, and you'll have over here this item. You have your amino group, your 2 bromine groups. Now we have to get rid of that amino group. It's a process which is called diazonation. There are multiple names, but this is a name, diazonation. D-I-A-Z-O-N-I-A-T-I-O-N, diazonation, because we're going to convert the amino group into a diazonium salt. And how do we do it? Sodium nitrite. NO2 is a nitrite, NO3 is a nitrate. This is sodium nitrite in the presence obviously of an acid, HCl, and you'll have here a diazonium salt to develop. An azo salt or diazonium salt, you can call it that. Diazonium salt is a better name. We have to get rid of it now. You've converted the NH2 into an N2, and it's a salt. We have a plus and you have a Cl minus. We can get rid of it by hitting it with alcohol, ETOH, ethanol, ETOH. it'll drive that off. In place of that, you'll have your hydrogen come up. And you know hydrogen is normally found in your benzene ring, and showing it is irrelevant because it's understood when something is not there, you have a hydrogen, and the ethanol got rid of your diazonium salt, and you end up here at your end product 1,3-dibromobenzene, and it's done. And thank you for watching.